Now recording. And share the screen. All right. So here we are. I'm going to use 7.5 today, at least some of it. I'm not going to start 8.1 at all until Monday. I still have it scheduled Monday. And remember, I still got all these buffer days, so I'm aiming to really slow down later, as we probably will need to when it comes to Trig. But if I have extra days at the end, that's great. I'll have my own review session, so to speak. Okay, so the way I have it planned for today is the first half will be lecture as normal on the new stuff. Okay, even though technically you're not responsible for it, and yet a lot of this stuff is a very nice review of Trig anyway. So we're kind of reviewing for the test tomorrow anyway, at least the Trig part of it. Now remember, for tomorrow's test, there's a portion that was not Trig, chapter 5, right? Exponential and logs. Okay. But some of the stuff that we're doing today, the new chapter, does apply very much so to the test tomorrow. Okay. Right, so the first half, I'll lecture on quote unquote new stuff, but it's kind of a review. The second half will be a review session. Okay, so whenever we break, I'll break as normal, and then the second half will be review, which means if you have no questions for the second half, you can sneak out and just leave. I won't count it against you for attendance, leaving early and all that stuff. Okay, Star and I will stick around if you happen to have any questions. Okay, the second hour. Okay, then tomorrow, just like the last time we had a test, I'll lecture probably for a very short time, 10, 15 minutes, then let you ask questions up to a limit of 12 o'clock again. But if you stop the question and answer session early, or maybe there's no questions, then we can have a real early break and then you just have more time for the test, just like last time, okay? So that's the strategy. So if you have any outstanding questions, ask today, second half. When it's break time, if you have no questions, you can disappear. And then Star and I will stick around if you have any questions the second hour, okay? And Star did put something in the chat, so thank you again, Star, for a possible review session. And I believe Mackenzie also gave you something earlier for review. So please use Mackenzie and Star for help. That's what they're there for. They're here to help you guys out on the test for tomorrow, okay? So reminder for tomorrow's test, whenever the break is over, then I will we'll have the normal 10-minute break, and then I'll send via Canvas announcements the exam. If anybody would rather not use Canvas announcement and want me to project it over here, I can do that. Just let me know if that happens to be the case, but if nobody wants it, then I won't do it. So during the test, you can have your one cheat sheet, your formula sheet, put whatever you want on the front and the back. Okay, but after that, no other help, can't use any books, notes, computer, cell phone, people, right? The usual for that. You can use a calculator. And during the test, you have to have your camera on for the exam and your true background. So don't have a fake background, but the true background is normal. During the test, if you have to get up and leave, let me know. Sure, you got to go to the bathroom. I get it. You want to take a break, get a drink of water, grab a snack. That's okay. But tell me that you're doing that. So if you disappear, say, hey, where did so-and-so go? Are they cheating or whatever? Okay, so just tell me, oh yeah, I had to go to the bathroom, I had to get a drink of water. That's fine. That happens to all of us. And just let me know so I can kind of feel of what's happening. So don't just disappear for no reason. Yeah. And during the test, if you have any question, put it in the chat. Please don't unmute yourself. Keep yourself muted. And yeah, about 10 questions, like I said. And coverage is chapter 5 and chapter 6. Since that's 10 sections, a very likely scenario is I give one question per section and go from there. Is that right? And so, as usual, I will close class at 1 o'clock. Last time, almost everybody finished early. So that's probably because we started early. So if you want to do the same thing, that's fine. Give yourself more time. So class ends at 1. You have until 1:05 to take a picture on your cell phone. So, just like on a quiz, click, 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 take a picture of all your pages and submit it to me, email it to me by 1:05. And then you have until 1:30 to submit the homework. Okay, but I'll accept the homework early. So my rule is that after the class before the test, which is today, you can start turning in homework. So once we finish class today, you may start submitting the homework, but I don't want it too early. Like if you submitted it yesterday, something, that's too early for me. Okay, but once today is over, okay, so when today is over, class is over, then you can start emailing me the homework if you already happen to have it ready. And up to the latest you can submit it is, what do we say, 1:30, half an hour after class ends, to submit the homework, okay? So that's what's going to happen. So any quick questions about the way the test works? Format, you've seen a couple of tests already, so you should know the style and what's going on. There's no trick questions, no surprise questions, okay? There should not be any of you that said there's any questions that are surprising or weird and so on. So if you can do all the homework problems here and here, chapters 5 and 6, you should be okay. Okay, so it's not my style to give any trick questions or surprise questions. Well, unless you didn't do the homework. If you didn't do the homework, then I guess everything's a surprise, right? Then, you don't really know what's going on. Right, so if you don't have any quick questions, then I'll just go ahead and get started with what I was planning to for today, which was 7.5. Okay, and again, a lot of this is a good review for the test anyway. So 1 to 37 odd. Again, I'll probably do every other odd to help you out. Okay, I don't see any other questions on the chat or verbally, so let's go ahead and get started. All right, so 7.5, 1 to 37 odd, page 519. Again, a lot of what we're doing will help you with the trig questions in the test. Okay, so again, for the benefit of those of you that don't have the text and don't plan on getting it, I'll quickly show it to you. Okay, well, I should show you the directions also. So there it is. I know I'm going fast, but again, you can always look at the video and pause, rewind, fast forward as much as you wish. 7, 9, 11. Okay, that's that. And then 13 through 23, verify the identity. Okay, and these are technically not to be used with a calculator. You're supposed to use the unit circle, and I'll show you how to do some of that. And looks like a few more triangle problems. So 25, 27. Okay, so it looks like some more on the next page. And let's see, how far are we supposed to go again? Supposed to go to 37. Let's see. 29, 31, 33, 35, 37. Okay, so there we go. Okay, question number 1. So 7.5, page 519. Okay, so they draw me this triangle. So I'll just do it fairly crudely to save time. They go 8, 15, 17. This is theta, and this is beta. All right, so this looks like a SOHCAHTOA problem for sure. Right, what's SOHCAHTOA? Sine of an angle is opposite of the hypotenuse. Cosine of an angle is adjacent over the hypotenuse. Tangent of an angle is opposite over adjacent. Okay. Okay, give the 6 trig functions of theta and beta, both. Okay, so again, the way I want you to organize it is sine theta, cosine theta, tangent theta. Let's always go sine, cosine, tangent, and then the reciprocal is right next to it. Reciprocal of the sine is cosecant. Reciprocal of cosine is secant. And reciprocal of tangent is cotangent. Okay. Then you may put SOHCAHTOA on your cheat sheet. Okay. And I do want to remind you, I say this often, but it is true. If we were meeting face to face, I wouldn't let you have this extra cheat sheet. Okay. By the time you take the next math class, maybe we're back on campus. I don't know, for the fall or spring 2022, but we're not sure. But your next teacher might make you memorize all this stuff. Just a warning ahead of time. Okay, we were told make things quote unquote easier for you because, you know, of the COVID situation and we're doing this online. So one way I'm making it easier on you is I'm letting you have this cheat sheet. But if we met face to face, I'd make you memorize all this stuff. Okay, so sine of theta, here's theta, opposite over hypotenuse, 15 over 17. Cosine of theta, adjacent, 8 over hypotenuse, 8 over 17. Tangent of theta is opposite over adjacent, 15 over 8. Okay. And yes, you could also say sine over cosine, 15 over 17 divided by 8 over 17. We know the way it works, so 17s would cancel out, just have 15 over 8. And then flip, flip, flip. What could be easier, right? 17 over 15, 17 over 8, 8 over 15. Right? So hope you should be able to get those pretty easily on the exam, especially. Okay, they tell you to do the same thing for beta. No big deal. The only difference for beta is the opposite is now the 8. The adjacent is now the 15. The hypotenuse stays the same, right? Hypotenuse is still 17. Okay, so sine beta, cosine beta, tangent beta. Okay, sine of beta, opposite over hypotenuse, 8 over 17. Cosine beta, adjacent over hypotenuse, 15 over 17. Tangent beta, opposite over adjacent, 8 over 15. Or you could say sine over cosine, 8 over 17 divided by 15 over 17. We know the way the game works. Cross out the 17, you have 8 over 15. And the reciprocals. Cosecant beta, secant beta, cotangent beta. Another thing I should mention, you should put the angle. If you don't put the angle, that's technically wrong. So in other words, students sometimes get lazy and just put sine, cosine, tangent, but don't put the angles. Okay, that's very technically incorrect. So you should put the theta or beta or alpha or whatever. So if you don't, I can take off points for that. Okay, it's not just cosecant, it's cosecant beta or theta or alpha or whatever. Okay, then just flip these guys. 17 over 8, 17 over 15, 15 over 8. All right, that's it. All right, so the problem's finished. I'll dig a little deeper, but we've said this before. The sine of theta is the same as the cosine of beta, right? 15 over 17, 15 over 17. So these two angles, which are called complementary, okay? Complementary angles add up to 90 degrees. You may have heard of that before, okay? These add up to 90. So the cosine of one is the same as the sine of the other. Okay, so likewise, cosine of theta is the same as a sine of beta, 8 over 17, 8 over 17. So there we go. Okay. All right, now this one, they gave you all three sides. They don't have to give you all three sides. Maybe they only give you two sides. You can figure out the third. Right. That would be like number 5. It says AC is 3, BC is 2, angle C is 90 degrees. Okay, so just make up such a triangle. So how do you know it looks like that? It can look anyway. I mean, you can make it look like that. You can make it look like that. It doesn't matter, right? Okay, angle C is a 90-degree angle. So how about that's A, that's B. So how do you know where's A, B, and C? It doesn't matter, but it does say C is the 90-degree angle. All right, AC is 3, BC is 2. So I need to find a hypotenuse. Let X. All right, so do my Pythagorean theorem. 2 squared plus 3 squared equals x squared. 4 plus 9 equals x squared. X squared equals 13. So x equals square root of 13. All right, they ask for cosine, sine, and tangent of A. That's the order they gave it to me. So he told me to give it like that. So we'll give it like that. So cosine is adjacent over hypotenuse. So 3 over radical 13. Sine of A, opposite over hypotenuse. 2 over radical 13. Okay. SOHCAHTOA. Tangent A, opposite over adjacent. 2/3. Right? All right, so hopefully that's not too bad. Okay, and then part B asks secant, cosecant, and cotangent of B. This is the reciprocal of cosine of B, reciprocal of sine of B, reciprocal of tangent of B. Okay, so cosine of B, adjacent over hypotenuse. So 1 over 2 over radical 13, radical 13 over 2. 1 divided by sine of B, adjacent, opposite over hypotenuse. 3 over radical 13, reciprocal of 3 over radical 13 is radical 13 over 3. Tangent TOA, SOHCAHTOA, right? So here's B, opposite over adjacent. So 1 divided by 3 over 2, 2 over 3. Okay. All right. That's that. Okay, problem number 9, I'm guessing is similar. AC is 1, BC is 3/4. All right, and you still have angle C as a 90-degree angle. Okay. So I'll just draw a similar picture. Okay, so they said AC is 1, BC is 3/4. Okay, so similar game. I need the hypotenuse. A squared plus B squared equals C squared. 3/4 squared plus 1 squared equals X squared. This is what? 9 over 16 plus 1, 16 over 16 equals X squared. 25 over 16 equals X squared. Take the square root of both sides. X is 5/4. So 3/4, 1, and 5/4. Okay, now in the original problem, it gives you part A, B, and C. The problem, I'm not going to write A, B, and C. I'm just going to do them all. So just write down all 6 of them, I guess. So it asks for sine of B. It asks for cosine A. Asks for sine A. Cosine B. Then tan A times tan B. Okay, sine of B. Opposite over hypotenuse. 1 divided by 5/4. 1 divided by 5/4 is 4/5. Cosine of A, adjacent over hypotenuse. 1 divided by 5/4. Again, it's 4/5. And that sort of piggybacks off what I said earlier, right? Sine of B is the same as the cosine of A in a right triangle. That's always going to be true. So come to think of it, I'm expecting these to be the same also. Sine of A and cosine B, right? Sine of one is the cosine of the other. So sine of A, opposite over hypotenuse. 3/4 divided by 5/4. Play the trick of knocking out the 4s. 3/5. So I expect this one also to be 3/5. Okay, but let's double check. Cosine of B, cosine adjacent over hypotenuse, 3/4 divided by 5/4. Yes, exact same thing. 3/4 divided by 5/4 is 3/5. Okay, tangent A times tangent B. Tangent is opposite over adjacent. 3/4 divided by 1. Tangent of B, its opposite is 1. Its adjacent is 3/4. Well, even though it looks funny, I can cancel these out. It's the same number here and here. So the answer is just going to be 1. So my answer is 1. All right, so that's how to do those. Now, some of these identities, verify the identities, do not use a calculator. So we're back to our unit circle. I see, 60-degree angles, 30-degree angles, and stuff like that. So we've played that game before. Okay, so let's try some of those. See, all the angles are first quadrant. So rather than wasting space and just doing the entire circle, let me just do the unit circle. $30 degrees, 60 degrees. Remember, for 30 degrees and 60 degrees, and all the angles whose reference angle is either 30 or 60 degrees, either the x or the y coordinate is a half, the other is automatically radical 3/2. Okay, so look at 30 degrees. The y looks like it's halfway across the circle, not the x. So 1/2 radical 3/2. This one's automatically going to be reversed. Let's double check. Right here, the x looks like it's halfway. Y looks like it's way more than halfway. 1/2 radical 3/2. Okay, so that's the picture that I want for these problems at least. Okay, so verify the identities. Cosine of 60 degrees equals cosine squared of 30 degrees minus the sine squared of 30 degrees. Okay. Behind the scenes, I'm kind of chuckling here. I know what's going to happen. There are going to be formulas that look like this later on. Okay. Where instead of an actual angle, they're going to be x. Okay. There's a formula cosine of twice an angle is cosine squared of x minus sine squared of x. Okay. If you have no idea what I'm saying, don't worry about it now, but it's leading up to something. The authors are getting us ready for that. Okay. So cosine of 60 degrees, x coordinate, 1/2. Cosine squared of 30 degrees minus sine squared of 30 degrees. So cosine of 30 degrees, y coordinate, x coordinate, radical 3/2. Sine squared of 30 degrees. Sine is y coordinate, 1/2. So we're asking, is this a true statement? Okay, radical 3/2 squared. Radical 3 squared is 3. 2 squared is 4. 1/2 squared is 1/4. So that's equal to 2/4, which is 1/2. So it's verified. It does check out. Okay, notice I just used a unit circle. I didn't pick up my calculator at any time. So you should be able to reproduce this picture. Okay. All right, we'll do a couple more of those type. 17. 2 sine of 30 degrees cosine 30 degrees equals sine of 60 degrees. Again, they're leading us up to an identity later on that involves double an angle. Two times that times that. Okay, cosine and sine of 30 degrees. Sine of 30 degrees, y coordinate is 1/2. Cosine is radical 3/2. Sine of 60 degrees, y coordinate, 60 degrees, radical 3/2. That's a 2 there. And yeah, that checks pretty easily. The 2's cancel out. So radical 3/2 equals radical 3/2. It checks. Okay, so that's all. And then let's see, one more like that. It's 21. It's a little bit harder. It says tangent 30 degrees equals sine of 60 degrees divided by 1 plus cosine 60 degrees. Okay, tangent is sine over cosine or y over x. Tangent can be thought of as y over x. Sine is y, cosine is x. If you haven't already done so, put that in your cheat sheet. So at 30 degrees, I want the y divided by the x. Y divided by x, 1/2 divided by radical 3/2. One half divided by radical 3/2. And we know we're going to change that to 1 over radical 3. Why don't I do that right now? The 2's cancel out. 1 over radical 3. Okay, sine of 60 degrees, y coordinate, radical 3/2, divided by 1 plus cosine of 60 degrees. Cosine of 60 degrees is 1/2. How can I get that to look like that? Let's see. How about over here? I'll multiply the numerator and denominator of the main fraction by 2 to make it look nicer. So that's going to cancel out. It's going to be radical 3 divided by 2 plus 1. Yeah, I see how it's going to work. On this side, if I now rationalize the denominator, go like that, and then it's going to work. Right? Radical 3 over 3 equals radical 3 over 3. So it is confirmed. But this was obviously a little bit harder. Okay, so one more time, what I did, tangent of 30 degrees, y divided by x at 30 degrees. So y was a half, x is radical 3 over 2. 1/2 divided by radical 3 over 2 is 1 over radical 3. Rationalize the denominator, multiply top and bottom by radical 3. So that gives me radical 3 over 3. This side, sine of 60 degrees was radical 3 over 2. The y coordinate. Divided by 1 plus cosine of 60 degrees is a half. X coordinate. Multiply top and bottom by 2. I end up with this, so it does match. Okay, so definitely a little bit harder, but we got to match. Okay. All right, then some of the problems at the end, sort of similar to SOHCAHTOA, only they give us a little bit harder stuff. They're not just numbers, they have stuff that involve variables like x and x squared or something weird like that. So let's see what we can do. All right, so 25 involves theta. So there's the picture there. So let me draw that picture. 25. Save time, I'll just freehand it. So they go 3, 2x, theta, alpha. Okay, and I'm just looking at what they have here. We're going to need this. But remember, theta plus alpha has to be 90 degrees, right? Recall, if I take the sum of the measures of the angles in any triangle, it's 180, right? 180 degrees. This is already 90. That means these two have to add up to 90 degrees. So among other things, if I subtract theta on both sides, alpha is 90 minus theta. The reason why I'm doing that is if you look at 25C, see how it goes 90 minus theta, 90 minus theta minus, okay, those are all alphas, essentially. All right, I got to figure out the hypotenuse. Over here, I called it x, but I shouldn't call it x because I've already used up an x. So pick another letter. How about h for hypotenuse? All right, so h squared is 3 squared plus 2x squared. H squared is 4x squared plus 9. So h is the square root of that. 4x squared plus 9. All right, so I figured this to be square root of 4x squared plus 9. Okay, now I can do my SOHCAHTOA. All right, so A asks for sine theta. I'm actually going to go across. They write for 25, sine, cosine, tangent, sine squared, cosine squared, tangent squared, and then a sine, cosine, and tangent of 90 minus theta, which I've now established to be alpha. Okay, so sine theta, cosine theta, tangent theta. So SOHCAHTOA. So sine is opposite over hypotenuse, 2x over radical 4x squared plus 9. Cosine is adjacent over hypotenuse, 3 over radical 4x squared plus 9. Tangent is opposite over adjacent, 2x over 3. And yes, you could say sine divided by cosine. If I take this divided by this, that radical stuff drops out. I just have 2x over 3. Again, part B, 25, it asks for the square of those. Sine squared, cosine squared, tangent squared. I just square them. Okay. And what happens when you square a square root? Just drop the square root. So 4x squared over 4x squared plus 9. Square this, 9 over 4x squared plus 9. And tangent squared is 4x squared divided by 9. Right? That's all. Okay. And for C, again, to make it easier for me to write, so again, notice for 25C, see how it goes 90 minus theta, 90 minus theta, 90 minus theta, right? I'm just going to write alpha, because that's what it is. Alpha was 90 degrees minus theta. So sine alpha, cosine alpha, tangent alpha. Okay. So here's alpha. Sine is opposite of hypotenuse, 3 over radical 4x squared plus 9. Or alternatively, notice here what we said. Sine of alpha is the same as cosine of theta. Okay, if I do the same trick and don't even look at the triangle, what should cosine alpha be the same thing as? Sine of theta. So I'll just copy that. 2x over radical 4x squared plus 9. Let's actually double check though. Cosine is adjacent over hypotenuse. Adjacent 2x, yes it is, and hypotenuse, that's correct. And tangent of alpha, sine over cosine, that divided by that, forget the radical, 3 over 2x. Okay, or alternatively, might be easier, then you don't even have to look at the radical. Tangent is opposite over adjacent. So alpha opposite is 3, adjacent is 2x, so 3 over 2x. So we get the same answer as you can see. Okay, I reached the end of the paper, so I'm going to turn the paper over, but let me do my focusing thing again. Show it to you quickly in case you say I can't read it. Again, I'm going fairly quickly. You can catch the video and pause the video as necessary. That's you. And that. Whoops. There you go. Some more. 25. Okay, so hopefully you can read all that. Okay, then 29. And I was pretty much going to stop after this. It'd be almost our break time anyway. Okay, so I'll stop at 29. We only had to go to 37. So tomorrow, I'll just do a couple problems, maybe 33 and 37. It'll be a very short lecture, maybe 15, 20 minutes tomorrow, and then questions and answers, and then we'll take our test. So hopefully, just like last time, if you don't have questions, we can start earlier. Or if you have any questions, you can ask it second half of today. Okay, so use the given information to determine the values of the remaining 5 trig functions. Okay, so I'll do 29. Tomorrow I'll do 33 and 37. Cosine of B is 4/7. Okay. Oh, it says the angles are assumed to be acute angles. That means they're all first quadrant. Okay. Whoops. Cosine of B is 4/7. Okay. There's actually two ways you can do this problem. They're both acceptable. Sine squared B plus cosine squared B is equal to 1. Okay. First quadrant, because it says acute angles. Acute angles means less than 90. All right, so if I do this, I have sine squared B plus 4/7 squared equals 1. Okay, so you should be comfortable both ways. Sine squared B plus 4/7 squared is what, 16/49 equals 1. Subtract. Sine squared B is 1 minus 16/49, which is 49/49 minus 16/49, which is 33/49. Get the square root. Sine B is square root of 33/49. Can't do anything with the square root of 33, but the square root of 49 is 7. Then I got the rest. So it says make a table. So all 6 trig functions. So this one I'll do sine B, cosine B, tangent B. All right, so let's see, radical 33/7. Cosine was what, 4/7. Tangent is sine over cosine. We know the way the game works. Radical 33/4, just forget about the 7s. And now we know what to do here. Reciprocal of sine is cosecant. Reciprocal of cosine is secant. Reciprocal of tangent is cotangent. Flip, flip, flip. 7/radical 33. And again, on the exam and homework and quizzes, you may leave it like this. You don't have to rationalize the denominator. 7/radical, just leave it like that. Flip, 7/4. Flip, 4/radical 33. Right, so I showed you how to do that before. So that works. Now I'll show you another way, but you have to be careful. I actually don't prefer this way because what students will tend to forget is that you might have to put a minus sign somewhere, okay, depending on what quadrant you're in. Here you're in quadrant 1, so it doesn't matter. So I'll show you another technique that works in this particular case. Okay, so method 2, I guess this would be method 1. Cosine B is 4/7. Okay, so I can make myself a real quickie right triangle. With angle B. Okay, cosine 4/7. Cosine is what? Adjacent over hypotenuse. Adjacent hypotenuse. Opposite. X squared plus 4 squared equals 7 squared. X squared plus 16 equals 49. Subtract 16. X squared equals 33. So X is the square root of 33. Right? And then you would do the same thing here. Okay? I'm just warning you, the danger of this method is you might end up putting everything as being positive, and you end up forgetting that depending on what quadrant you're in, one or more of these might end up being negative. Okay, so I'm just warning you about that. That usually doesn't happen as much when you do this technique over here. Okay, so if you want to do this, it's fine. You just have to remember, okay, the sine might be negative or the tangent might be negative. Okay, just do your all students take calculus thing, right? Like if it says I'm in quadrant 3, that means sine and cosine are negative, tangent's positive. Or if it's in quadrant 4, cosine is positive, that means sine and tangent are negative, right? So watch out for stuff like that. And there we go. All right, I'm done, folks. Let me just go back and do my focusing job here. And there. Okay, and that's as much as I was going to show you. Okay, so I'm finished today, folks. Tomorrow, I will do just 2 more problems from the same section, questions and answers, break, and then the test. Okay, so it's a little bit before 12. Okay, let me stop the share. So it's quote unquote break time as normal, but if you have no questions, you can just sneak out. I won't mark you as absent or whatever. So at 12:10, if you stick around, it means you're going to ask questions of Star and me. But if you have no questions, then you may leave and I'll see you tomorrow. You can start turning in homework. Okay. All right. So we'll break quote unquote until 12:10, but you can
You're muted.
Thank you. You're right, I'm muted. Okay. So welcome back, everyone. So just like Monday, I'll split half of you up into a group with Star and half of you with Mackenzie. You can stay as long or as short as you want. And for Star and Mackenzie, if your group gets a little bit too big or too small, I might move somebody over. And I think I've given share screen options to you. So if you need to, Mackenzie or Star, you should be able to share the screen. You can put something in the chat. I'll be able to answer you back from the chat shortly there also, okay? So I'm gonna break you up into groups, just like Monday. If any group gets too big, I might move somebody over. And then whenever it's over, okay? So let me go ahead and do that now. And let's see. Okay, yeah, anybody who has a quick question, you can put it in the chat, like grades and attendance, go ahead and do that. And then you're still welcome to leave whenever. Okay, so let me set up the breakout rooms quickly. And we'll go right to that. Okay, you can join your breakout room. Some of you are with Mackenzie and some of you are with Star if you want to. But if you're not joining a room or we don't hear from you, then I'll assume you're not there. I'll be in the main room if anybody wants to reach me. Okay, Kimberly, did you have a question? Or Justin, did you have a question? Okay, Justin, did you have a question? Otherwise, you don't have to stay.
Professor, can you put me back in the room with Mackenzie?
Okay, let's see. It's Jake?
Yes.
Okay, all right.
And it just says to evaluate it.
Everyone, just interrupting real quickly. Right now, it just turned out that there's only one room. If anybody wants to break up and, I can have Star go with somebody and Mackenzie with somebody else. It's up to you. Or if you're happy just being all together for now, that's okay too. Okay. And I'll be in the main room if anybody wants me there. Okay. Thank you.
Okay.